Hey 8th graders, we're moving on today. We're getting really close to being done with this unit, and you know what, I think you guys are going to be happy to hear, but after we get to the end of this is it. I mean, we're going to finish this up and we're going to have a quiz, and that will kind of close out our school year. So it's crazy to think that we're getting that close to the end. So today we're going to talk about linear equations, okay? Like we have been talking about, but specifically their intercepts. Now an intercept is where something crosses. Think about intercepting a football, or where the road intercepts another road. So when we talk about the x-intercept, this means where the graph or a line crosses the x-axis, and the y-intercept is where a graph crosses the y-axis. Okay, so it says let's find the x and y intercepts of the linear equations graph below. So these are already graphed for us, and so basically your job is to find where they cross the x and y axis. So if you start on the first one, the x-intercept is where it crosses the x-axis. So it crosses right here at -2, and the y-intercept is right here at +4. Now, moving on to the next one, the x-intercept, remember that's your horizontal, is right here at +3. Your vertical, the y-intercept, is at +2. Last one here, this line is graphed for us. The x-intercept, it's not perfect, okay, so it's kind of hard to tell. The y-intercept we know, and that one is -3. So this one I'm just going to kind of leave that question mark because it's not perfect, and so it's difficult to tell. So since the x-intercepts occur when y is 0 and y-intercepts occur when x is 0, we can find them algebraically. Okay, and that's what would help us in this situation, or if we didn't have a graph. So one thing that I want to show you here is that if we were actually to give the coordinates of this intercept, this would be -2, 0, and this one would be 0, 4. So this is saying when y is 0, that's our x-intercept, and when x is 0, that's our y. So it's kind of like the reverse of each other. This one would be 3, 0, this would be 0, 2, and then this would be the reverse. This would be 0, -3. So because we know this little tidbit, we can solve this algebraically, because as long as you're only missing one variable, you can find the other one. So what we are going to do, and I'm going to show you two different methods. So the first method is what happens if you just have the equation like this. For the x-intercept, what you're going to do is you're going to plug 0 in for y. So you're going to take this equation and you're going to put 0 in for y. So it's going to be 0 equals 2x plus 4. And then you're going to solve it for x. You're going to move the 4 to the other side. You get -4 equals 2x. Divide both sides by 2. -2 equals x. So your x-intercept is -2 when y was 0. Okay. The next one, for the y-intercept, you're going to plug 0 in for x. So now we're going to take that same equation, but instead of the y being 0, we're going to put the x as 0. Okay, and so what happens here, we end up getting y equals 2 times 0 is 0. So what's y? Is just 4. So this one is 0, 4 for your answer. And that's how you find the intercepts algebraically. So if we had the equation in this one up here, we could solve that one algebraically, which we are going to do right here. Okay, so I'm going to show you what happens here. This is in standard form, and when an equation is in standard form, there's a trick that we can do. I'm going to show you here what it's going to look like algebraically. So first I'm going to plug a 0 in for y. So I get 2x plus 3 times 0 equals 6. Well, what happens here? The zero's out, and you just get 2x equals 6. And divide both sides by 2. X equals 3. Then I'm going to do the other one, and I'm going to put the 0 in for the x. what happens is this zeroes out, and we get 3y equals 6. Divide by 3, y equals 2. So this is the coolest trick, I think. I'm going to show you. We can use what is called the cover-up method when a problem is in standard form. So I'm going to give you a problem that is not on here. So I'm going to give you, let's say, 2x minus 6y equals 12. So this is our different problem. This is just for you guys to watch. So what happens when we put a 0 in for y? Do you notice that term just disappears? Okay, so this is why it's called the cover-up method, because you can cover up, well, so that's kind of hard to see, sorry. Maybe I'll try with my pen. You can cover up the y term, and you get 2x equals 12. So if you want to solve the x, you cover up the y term, and you get 2x equals 12, divide both sides by 2, x equals 6. Okay, so now let's cover up the x term to find the y one. So I now have 2x minus 6y equals 12. You cover up the x term, you get negative 6y equals 12. Divide by negative 6, divide by negative 6, x equals negative 2. Now the reason why we can use the cover-up method is because you guys should know when you put the 0 in, it just gets rid of that whole term. So the cover-up method is what you can use when an equation is in standard form. So you can use that method to find the intercepts when something is in standard form. So if you guys like, I can do that with this one. So if I was going to find the x-intercept, I need to cover up the y, and it's kind of hard because I've got that shadow. But this is going to give me 4x equals 3. Now this is where we're going to get that not nice number because our graph wasn't perfect. The x-intercept is a 3/4, which looks about right. And then if I cover up the x term, I get negative 1y, I put a 1 there, equals 3. Divide both sides by that negative 1, y equals negative 3, which was our answer from up here. So that just shows that we did it right. So this one is going to be 3/4 and 0, and 0 and negative 3. So I know that those three examples all looked a little bit different, and I showed you this cover-up method, but I hope that makes sense. You could take this equation and you could get it in standard form. In fact, that's what I teach a lot of times, is you would just take this equation, you would move the 2x to the other side, and then you could use the cover-up method to do that one. So for example, y would be 4, which is what we got. And in this one, you'd have negative 2x equals 4, divide by negative 2, divide by negative 2, x equals negative 2. So it works that way too. So if you like the cover-up method, go ahead and do so. That's just a little trick we know. Moving on here, it says sometimes it's easier to sketch lines by finding intercepts than using the slope-intercept form. Okay, so if it has a funny slope or it's a difficult graph, just plotting 2 points on the intercepts is going to be easier for us to make a graph than it is to find the slope. So let's say that Pam is going to spend $1,080 on printer paper for the office. Paper X costs $20 per case, paper Y costs $30 per case. A linear equation representing the different paper combinations she could order would be, so you've got 20x plus 30y equals 1,080. So these are going to provide all the different combinations to just spend that, if she had a budget there. Okay, so, and then this says, for example, one possible combination would be 33 cases of paper X and 14 cases of paper Y, because if you plug them in, they equal that. But it's kind of difficult to plot those numbers on here as well. So, since these numbers are so large, sketching this graph will probably be a bit easier by finding the intercepts. And I'm going to show you why. If we take this equation, and we're going to get y by itself, to get it in slope-intercept form. That's how we have been graphing things. Let's do that and just see what it looks like. So I'm going to move that 20x to the other side. And I get 30y equals negative 20x plus 1080. Then I'm going to divide both sides by 30. And remember, you've got to divide everything by 30. So y equals, this ends up being, it reduces to negative 2/3 x. Let's take that 1080 divided by 30. And I get 36 here. So that means I'd have to go to my graph, I'd have to try to find 36, but then I could only go up 2 over, or down 2 over 3. And the tricky thing is that these don't go by ones, or your graph doesn't go by ones, and so that makes that more challenging to graph a slope of 2/3, negative 2/3. So if we use our intercept method, I'm going to put the zeros in just to show you. The x-intercept means that I'm going to put the 0 in for the y. Okay, you could use the cover-up method to do this too, because you can see what happens. So I get 20x equals 1080 divided by 20 divided by 20. X equals 54, I think. Yeah. Okay, and then I'm going to do the y-intercept afterwards. The y-intercept means the 0 is going to go in for the x. So it's 20 times 0 plus 30, y equals 1080. So this zeroes out, so that could be like the cover-up method if you like that way of looking at it. Divide both sides by 30. Y equals 36. So I should have known that because the y-intercept's right there. Okay, so now you can go to your graph, which is up here, and we can plot this a little bit easier. So the x-intercept is 54. If this goes by 0 to 20, that means that each one of these, 5, 10, 15, 20, is a 5. So 54, this would be 50. 54 would be like right here. And my y would be 36, so 20, 30, 35, 36. So that on this graph is going to be much easier to graph and get a more accurate graph just because of the scope of the numbers. So anytime you have 2 points, doesn't matter if there are 2 points given, your intercepts, a slope, a point and then a slope. Anytime you have 2 points, you can make a line. So this would be 54, 0, and this would be 0, 36. Okay, last problem. We are just going to do this equation as well. It's in standard form, so I'm just going to encourage you to use that cover-up method. If you put a 0 in for the x, you can cover that up. I'm going to find the y-intercept first. Negative 15. Y equals negative 1200. Divide by negative 15, divide by negative 15. Y equals 1200 divided by 15 equals positive 80. So that was when x was 0. So 0 is my x. My y is 80. So now I'm going to do the other one. If you can see that, I'm covering up. I'm going to put the 0 in for my y term. So this gives me 20x equals negative 1200. So I covered that up. Okay. Then I divide both sides by 20. X equals, so I just think of this, 120 divided by 2 is 60, negative 60. So my x-intercept is negative 60, 0. So then I can go to my graph here, and my y-intercept is 80. Looks like it goes by 10, so 50, 60, 70, 80. And then my x-intercept is negative 60, so that would be right there. So on a larger graph or one that doesn't go by ones, this is a really useful method to graph a line. So I hope that that makes sense. I know I actually didn't really have a ton of examples. Just remember that the intercepts means where it crosses, and keep in mind that this is the x-intercept, so it's in the x place. That means y was 0. The y-intercept, the x was 0, and the y was a value, which is a number. Okay, and that should help you when you're trying to figure that out. So your homework is just this one page right here, and so I just want you guys to do that. And then I have an IXL for you. And then I'm actually going to teach this for you guys tomorrow. So we'll talk to you later. Hope you guys are doing great.